Hi folks, Joseph Kursky here with you to review the River Trace tool by Sam Lerner. You can see the URL right here. It runs in a browser, no login or sign in required. I can click on different river sources, mouths, but ideally near the headwaters of a river, and then trace in a 2D and a 3D scene the terrain as the river flows down the course of it. This is a great tool to teach with in physical geography, geology, earth science, environmental science, and even in other courses looking at land use, land cover. As I roll down the Great Plains here on the South Platte River now, you can see that I dropped the pin on Central City, Colorado. I went down North Clear Creek, South Platte. I'm going to get to the Platte River and the Missouri River. Notice I can skip ahead if I want. I can play the animation fast or slow, and it's all using spatial data from a geographic information system rendered in this very clever tool that Sam Lerner has created. I would use it as a supplement. For example, there's a tool in ArcGIS Online where you can trace downstream. So you can trace it in the ArcGIS Online environment, and then you can actually visualize it here. So those two tools together are quite powerful to teach about watersheds and land use along watersheds, and what happens if something's spilled into the river. Where does it go? Where do cleanup efforts need to be focused to mitigate that spill, etc.? What kind of drainages? What happens to rivers when they widen and meander back and forth? So you can start to see here, we're looking at the Mississippi River now. I can back up if I want to also. I'm going to look at the confluence of the Mississippi and the Missouri right here just north of St. Louis. That's right in the background of this satellite image, looking at it in an oblique way right here, which I think is a powerful way to get students to understand the landscape, land use, land cover, what kind of tree covers, what crops, what landforms are acting to influence the course of the river, and how does, in turn, the river act to influence the landscape, and also how do rivers influence human settlement, and should we be building along major rivers? All kinds of questions you could ask the students. I'm going to play it in a fast motion now. You can see the river meanders in the lower Mississippi now, and you can see it on the small map right there as well. You can run trace downstream in ArcGIS Online for most parts of the world, but this particular river trace tool is only good for the U.S. because it's using some USA data. But fascinating and powerful to be able to do this. Notice how the meanders get wider and wider. The river gets, of course, longer, wider and wider as well, carrying more volume. You can also, in ArcGIS Online, supplement this lesson with looking at the river gauges, the stream gauges. So look at the volume, do a little mathematics, calculate flow, volume. How many bathtub loads go by this stream gauge every minute, every 3 minutes, every 5 minutes? That's a lot of bathtub loads if you're getting down to the lower Mississippi. By contrast, the streams at the headwaters of many of these are so that you can actually walk across these rivers. For example, many of the rivers here in Colorado near the source of the Arkansas, the Platte, the North Platte, and depending on where you click, right, there's a vastly different route that the water takes from source to headwaters. I'm clicking on east of the drainage divide in Iowa, and then west of the drainage divide, and then east of the drainage divide, and then also get the students to think about, hey, not all rivers in the continental USA flow either directly to the Mississippi or to the Missouri or to the Colorado River or the Columbia or the Ohio. If I clicked on northern Minnesota, northern Wisconsin, I see the drainage going up into Manitoba, the Red River drainage system. Also, what's fascinating to me is you go close to the Great Lakes like I'm doing right here, and the east side versus the west side of Chicago. And this is a influence of human impact on the landscape, where many of the drainages that actually flowed east into Lake Michigan were diverted to the west so that shipping could take place. That's actually a really interesting story of the history of Chicago, how those rivers were actually, that's when you think about the 19th century engineering behind that. And then choices that we make on the landscape. What influence did that have on future settlement, future trade, future land use, future habitat for aquatic species, and future fish populations, etc. And there's pros and cons with all these major water projects, levees, diversion of rivers, etc. So just being able to do that for a large scale, like we're just zooming into central neighborhoods in Chicago, and to a small scale. And I can do the same thing looking at urban rivers right here through Joliet, where Jake and Elwood Blues hung out, and on downstream through the Illinois River down to the Mississippi in this case. But fascinating to be able to do this. You can click in the Great Basin. Why don't rivers flow out of the Great Basin? I'm not doing that in this video, but you could certainly do that with this River Trace tool. And what happens when water flows into the Great Basin in a year or 2 years or 3 years where there's a high precipitation? You could show students stories of the Great Salt Lake being quite full, threatening some of the northwestern Salt Lake City neighborhoods back in the 1980s when there was a lot of precipitation. It's a great basin. Rivers flow into it, and they can't flow out. So how does water get in and out of basins? What influence do basins have? Do rivers have on human settlement? What influence do humans have on rivers? All that and more. You can help foster the learning of in a dynamic environment, for example, with this River Trace tool. Thanks.